Okay, next topic is dielectric constant, well represented by a capital letter K, and it is also known as relative permittivity. So let's discuss about it. So what we'll do is we'll consider two cases, case 1 and case 2. Case 1 is when the 2 point static charges are placed in vacuum or free space. Case 2 is same 2 charges Q1, Q2 are the same separation but placed in some medium. We know that the the electrostatic force or Coulomb force does depend upon the nature of the medium in which the 2 point static charges are placed. So in both this scenario, although we are taking the same pair of charges, the same separation between them, yet the force experienced in these two cases would be different. So in this case, F vacuum would be given by 1 over 4 pi epsilon. This is the absolute permittivity of vacuum or free space, right? Q1, Q2 by R square. Put this as equation number 1. In the second case, it will be 1 over 4 pi epsilon. This is the absolute permittivity of this medium. Remember, permittivity, it indicates the nature of the matter involved. Its value is different for different medium. For vacuum, its value is least 8.854 into 10 to the minus 12 Coulomb square per Newton per meter square. While for some other medium, its value is different. Right? Epsilon would be greater than epsilon. So what I mean to say is that the value of small letter k or the value of epsilon or the value of f, it does depend upon the nature of the medium in which the 2 charges are placed. Epsilon naught, it denotes absolute permittivity of free space or vacuum. Vacuum is free space. Epsilon is the absolute permittivity of this medium in which the 2 charges are placed, other than air, vacuum or free space. So, if we divide second from first, what we get is F medium divided by F vacuum. It would be epsilon divided by epsilon, or F vacuum divided by F medium. It would be equal to epsilon divided by epsilon, isn't it? This ratio, that is F vacuum divided by F medium, what we get is epsilon divided by epsilon. This ratio is known as dielectric constant. It is represented by capital letter K, or it is also known as, this is the symbol for permittivity, epsilon and R, relative. So it is also known as relative permittivity. It is also known as relative permittivity. So this is again a very, very important concept. So dielectric constant of a medium is defined as the ratio of the absolute permittivity of the medium to the absolute permittivity of free space. In other words, dielectric constant or relative permittivity of a medium may also be defined as the ratio of the magnitude of the electric force between the 2 point static charges when it is placed in vacuum to the magnitude of the force between the same 2 charges separated by the same separation but when placed in that particular medium. So K can be defined in both ways. One more important point to be noted. K or epsilon R, that is the relative permittivity or dielectric constant, is the ratio of 2 similar physical quantities. So it is a dimensionless quantity having no unit. The value of K is different for different medium and it is a dimensionless quantity having no unit. Let's consider some example. We can rewrite this expression in this manner as well. F medium, it may be written as F vacuum divided by K. Now, as I have told you, epsilon as least value. For vacuum, the value of permittivity is minimum. Any other medium will have value of permittivity greater than epsilon naught. So therefore, epsilon over epsilon naught is always greater than 1. Or K, capital K, which is dielectric constant of any medium, is always greater than 1. For any medium, the value of dielectric constant would be always greater than 1. So there's a very important conclusion. Look, from this particular equation, since the value of K is 1, therefore F medium would be less than F vacuum. Is it clear? There's a very important point to be noted down. F medium is always less than F vacuum. Denominator is greater than 1, therefore F medium would be less than F vacuum. So what's the conclusion? The magnitude of the electric force between the 2 point static charges when placed in air or vacuum is maximum. When the same 2 charges at the same separation are placed in some other medium, the magnitude of the electric force between them tends to get decreased. And that's the relationship. F medium is F vacuum divided by K. So in vacuum, the magnitude of the electric force between the charges is maximum, while in some other medium, it will become 1 by K times than in case of vacuum. So, the magnitude of the electric force does depend upon the nature of the medium in which the 2 point static charges are placed. I'll give you an example, a simple example. The value of dielectric constant of water is approximately 80. 81, you can consider 80 approximately. The dielectric constant or relative permittivity of water is about 80. So, when these 2 charges are placed in water, maintaining the same separation between them, then the magnitude of the electric force between these 2 charges will get reduced by 1 by 80 times. Understood now? So, in vacuum, the magnitude of the electric force is maximum, while in any other medium, it will get reduced. So that's the concept of dielectric constant. The dielectric constant is defined as either the ratio of epsilon to epsilon naught or the ratio of F vacuum to F medium. And it's a dimensionless